Hi guys, welcome to this tutorial. In this tutorial, I'm going through everything you need to know about LCDs. Why? Because they're so useful. You can see them anywhere, they're so popular. You can see them on screens, televisions, anywhere you're looking at, and you see them in many projects. So if you're doing a project and it uses LCD, this video is for you. This tutorial has three parts. The first part is the connections and a bit of explanation of how LCDs work. The second part is commands and coding of the Arduino to connect LCD. And the last part is the results, and yeah, that's it. So for the first part, we're going through it, and let's start. So I do a bit explanation about LCDs. Why they're so popular? Because their price is so low, and they can show numbers, characters, and graphics. They can show anything, and it has some types. Here we're using a character LCD which has 32 characters to show. It has 16 columns and 2 rows, so it is 32 characters. And LCDs has 16 pins. So let's explain the pins and how to connect them to Arduino. The first and the second pin, which is VSS and VDD pin, goes to GND and VCC, um, negative and positive of the Arduino. And V0 or VEE is for controlling the contrast of the LCD display. For controlling the contrast better, we use a 10K potentiometer, so we can use them with a trimmer, so it's so easy to adjust whatever level we want to. So we connect the third min right to potentiometer, and then the fourth. Let me explain the RS, RW, and enable pins. What are they? RW pin is read or write pin, which means if you connect RW to ground, it's for writing on LCD, and if you connect RW to 1 or VCC, it's for reading from the LCD. So here we're going to write to LCD, so we connect RW to ground. RS is register type, which means we should choose what type of registration we need. If RS is connected to ground, is for sending commands. We sending commands of like how I explain later. The commands of liquid crystal library, if you want to use them, the RS pin should connect to ground. And if we want to just send data, the RS should connect to VCC. And what is enable? Enable actually means it has a pulse. It sends pulse for enabling the data pins. When the data pins go through the datas, it enables and pulses to activate the data pins and to start the connection. So it's just an enable thing, and here we should choose how to connect the LCD to Arduino. We have two kinds of bus. We have 4 data pins bus and 8 data pin bus. What's the difference? I mean, 8 data pins means we connect D0 to D7 pins to Arduino, and 4 data pin bus means we connect D4 to D7 pins to Arduino. And what's the difference? Actually, it doesn't have any special difference. It just when we want to use just 4 pins of data, it takes twice the time when we use 8 pins of data, because LCD use 8 data, because the characters and LCD, it uses 8 bits of data. So when we want to receive 8 bits of data from the LCD, we should use 8 data pins. So if we use 4 data pins, it just takes twice the time. And because the time is so little, it doesn't have any special difference. And also, if we use 4-pin data bus, it's better because the libraries we have, like Liquid Crystal, is designed for data pins. It can be for 8 data pins too, but it's so much easier because it also takes less pins, which is important, like in boards like Arduino Uno. Less pins is so useful for us. So yeah, I just said it's better for 4 data pin bus. So D0 to D3 is not connected, and we just connect D4 to D7 for pins of Arduino. So yeah, RW to ground and enable to pin 3, RS to pin 2, enable to pin 3, and D4 to D7 go for 4, 5, 6, and 7 pin. And the last 2 pins are for LED backlight. There's an backlight LED behind the LCD, and these 2 pins are for powering the LED. So as it is a LED, we use a 330 resistor and then connect it to VCC, and the A goes to VCC and the K pin goes to ground. So yeah, these were the connections, and yeah, now we're going through the second part of the video. Welcome to the coding part. In this part, we're going through the commands of Liquid Crystal library. As the first step, we should just include the Liquid Crystal library. So we write liquidcrystal.h. Then as the second step, we should define a variable to call the Liquid Crystal library. So we write here as you can see in schematics, I used these pins for connecting LCD to Arduino, and the LCD is the name of the variable I use for calling the Liquid Crystal library. So then we have another step that should be lcd.begin. What it does is it set the dimensions of the LCD we have and initialize the dimensions for the Arduino. Here the first number is the number of columns and the second number is number of rows. Here I have a 16 add 2 LCD, so I use 16 and 2 numbers for the dimensions. So we're done for the setup thing, and we should go for the commands. The first command I want to talk about is lcd.print. One thing, guys, as you see, I used 6 pins for the liquid crystal library to connect the LCD. It has 4 formats. You can use whatever you want, but let me tell you what are the 4 formats. Let me copy this. As you see, for the 6 pins I use, I write the names. In this format, you write the RS pin, enable pin, and D4 to D7 pin. The second format is you can use RS and RW, and then enable and D4 to D7. And as you know, we use 4 pins for data pins, and we can use 8 pins of data for connecting the LCD. So as we have 2 formats for data pins, we have 2 formats for 8 data pins. So it goes the difference is just usage of 8 data bins instead of 4 data bins. So but the first format that I use is much easier, and you don't need that. So back to the commands. As I said, the first command I'm going to talk about is lcd.print. We write it like this, and what it does, it just prints the data. The format is lcd.print data, or it can be lcd.print data and the base of that data. Let me write an example for you for better understanding. For example, I want to write down a name, maybe just LCD tutorial. What it does is just show this on the LCD. So the easiest thing of the LCD print is this, and the second one is data and the base. For example, what this command does is just writes the 255 on the LCD screen, and this is a decimal number. But for example, you want this for showing on LCD screen as a binary number or hexadecimal number, so you can use this. So now it shows the 255 number as 8 ones, which you know the format of binary is like 8 ones for 255. So you may ask what data and what kind of bases you can use. So I write it here. The kind of data you can use is you can use character or byte or integer or long and string. You can use these kind of datas in the parentheses of LCD.print, and like this example, you can use all the bases you know, which is binary or decimal or octal or hexadecimal. Be aware that you should write these the first three letters, and it should be capital, like binary, as I wrote it here. So this was the LCD.print, and the next command I'm going to talk about is LCD.setCursor. As is obvious from the name, it sets the position of the cursor. So the position has column and rows, so it has two numbers. Here I write 0 and 0. The first number is for the columns and the second number is for the rows, and be aware that it starts from 0, not 1. So when you want to start the cursor from the first row, you don't write the second number 1. It is 0, and because it starts from 0, and as we have two rows, the second number should be either 0 or 1. So let me write a better example of these two commands. And put a delay of 1 second between these. Doesn't matter, but yeah. So I show that later, but this is the start of the typing the LCD tutorial. Columns and rows. The 4 is columns and the 1 number is rows. So the next command is LCD.clear. It does two things at the same time. First, it clears the LCD, whatever on the LCD screen, and the second thing, it sets the position of the cursor at the top left, which is 0 and 0. So when you write this command, it clears all the things on the display of the LCD and then sets the cursor to 0 and 0. And let's go for the next command. It's LCD.home. What it does, it positions the cursor in the upper left of the LCD, which is 0 and 0. And you may ask, what's the application of this command? It's for when we want to show subsequent text to display in just one character of the LCD. For example, we write hello world here. What we want to do is we want that letters pass by one by one in just the first character of the LCD. First character of the LCD when we print hello is H. So it's not complete. We should use lc.clear too. So for example, when we want to use lc.home, it prints the H letter of the hello, and then H passes by and E comes to the first character, which is H. So we have a scroll that is just for the first character of the LCD. I show you later for the better understanding, but I just have a short description here. And yeah, the second thing here is lcd.write. It's different from the lcd.print, and I'll explain that. It has many usage of for the LCD screens and displaying and projects. The simple thing is just what it does, it prints a character, so you can just easily write lc.write character X, and it writes the X character on the LCD screen. And the second application I want to talk about, and it's really interesting, is when we want to put an input to show on the LCD screen. So I write the coding first and then explain it to you. So in setup, we start the serial monitor with 9600 beats per second, which is the default of serial monitor speed, and we can use many things for input, like keyboards, keypads, and anything. But here I want to use serial port for the input, so I use serial. First we do this in setup, and then we say if the serial is available, if we go to serial monitor, it makes it available, and then in the if we write lcd.write serial.read. Oh, one parenthesis left. So what we write in the serial monitor as input, when we send that, it serial.read reads that thing we wrote. It can be a number, it can be a character, a word, anything, and then lcd.write writes it down on the LCD screen. And you can, for example, you can see here, I open the serial monitor, I want to put an input as hello, and when you send that, the hello shows up to the LCD screen with this command. The next command is lcd.cursor. So let me delete these. lcd.cursor. cursor. So what it does, it displays the LCD cursor at the position to which the next character will be written. It means when I write the first letter of hello, for example H, then at that moment the cursor is at the second character of the LCD, and it's always one space ahead of the letter is typing on the LCD. And it has another command that is lcd.no cursor, which just it turns off the lcd.cursor. It's the opposite. If you want to have a blinking cursor, you can have this code. Example, first you turn on the cursor and a delay, and you turn off the cursor. So with these three you have a blinking cursor. The next command is lcd.blink. What it does, it displays the blinking LCD cursor, and like the lcd.cursor, it has a opposite one, which is lcd.noblink. lcd.noblink turns off the lcd.blink. So lcd.blink turns on a blinking cursor on the LCD. You may ask why, what's the difference between lcd.blink and lcd.cursor. The difference is size of the blinking cursor or the cursor. I mean, when you use lcd.blink, it makes a cursor of a full room of a character of LCD, which is 8 columns and 5 it is 8 add 5 pixels. As you know, every room, every character of the LCD has 5 columns and 8 rows, so it has a full room of the character, so it's a big cursor. But in the lcd.cursor, it's just the first column of the pixels, so it's different in the size. The next command is lcd.display. It has opposite the opposite command right here. So what it does, it turns on the LCD display after it's been turned off with a no display command. It means the LCD.display doesn't do anything on its own. You should turn off the display first and then use this for turning on the display again. It's not like LCD.clear that clears everything that is on the LCD screen. It restored the text and the cursor that was on the display, and just display and not displaying it. It does nothing have to do with the texts and the cursor on the LCD. It saves that. The next command is lcd.scroll display left. So what it does, it scrolls the contents of the display, and it can be text or cursor, one space to the left. And we have another command that is like the previous one, it's just right. So and this is like the previous one. It scrolls the content one space to the right. It's so simple. And the next command is LCD dot auto scroll. So what it does, it turns on automatic scrolling of the LCD. Let me explain it more. It pushes the previous character over by one space. So for example, when we print hello on the screen, the next hello is just after that hello. It automatically scrolls the letters that we wrote on the first print or write. And the important thing is the directions. If we use LCD.AutoScroll, the direction is opposite of default. For example, whenever you write anything on the LCD, the default direction is left to right. So when you use LCD.AutoScroll, the display scrolls to the left. It means the opposite direction of the default writing direction of the LCD. If the direction of writing on the LCD is right to left, the display scrolls to the right. It's always opposite. And it has opposite command like the others. That is this command. No auto scroll. It turns off auto scrolling on the LCD. So the next command is LCD.left to right. LCD.left and it has also LCD.right to left. So what it does, it set the direction for text written to the LCD to left to right, and that is the default. This means that subsequent character written to the display will go from left to right and does not affect the previous character. It just scrolls to the right, and the second one, it just scrolls to the left. It's so simple. And the next thing is, and the most important command, and it's also the last command, is when we want to create a custom character which can be used for creating graphics, shapes, and anything, stickers. So what we write is lcd.create char, and the format is num and data. Let me explain first. What it does, it creates a custom character for use on the LCD screen. It can be up to 8 characters, which is 0 to 7 numbers for creating custom characters. As I said before, every character of the LCD has 5 columns and 8 rows, which is 5 at 8 pixels. So we use each of these pixels for showing a custom character and a custom shape. So it has some definitions. Let me write it down. Before the setup, we should define the pixels of the custom character first. As it has 8 rows, we should use byte. We should use byte and also an array for each of that rows. So here we write, for example, here I want to create a custom character of a heart shape. So I name it heart. The heart is the name, so it can be anything. Let me write it, then I explain. So the format of the definition is like what I write it here. It should be a byte variable, the name of the variable, and the definition of a 8 thing variable of array. So as we have 8 pixels, it should be a 8 room of array. We can write it here 9 or just let it be empty, as it can be any number. So the first definition is before the setup, when we want to write down the custom character and what pixels should be on. So the zeros of each character here is the pixels. When a pixel is 0, it's off. When a pixel is 1, it's on. So you can imagine whatever shape you want to make, and put zeros and ones to it, and that it can turn off and on the pixels. And in the next step, you should use this and so let me explain that to you. Remember, I said the format of the create char is like this. The num is which character to create. As I said, it can be from number 0 to 7, and data is the character's pixel data we want to show. So delete this. As you see, the num is 0 and the character of the pixel is which is data is the variable name, which I defined before in this line. And remember to use set cursor with any number, 0, 0, 0, 1, anything. because if you don't use this, it doesn't work. And what it does, you define the pixels of the custom character in this line, and after that you should use that variable name with lcd.createChar function, and then you set cursor, which is you set the position you want this create char and the custom char to show up. And the next thing is to just write that on the LCD. Here, one important thing is when you put 0 here, it should be 0 here too. These two numbers should be equal. And yeah, that's it. I went through any commands you need for your projects, which includes the LCDs, and hope you enjoyed that. Hi guys, this is the last part of the video. As we said, this is the part that the results of the code that we wrote in the part 2 is showing here. So let's see it together. But make sure you check the description. Everything that I wrote and talked about is in the description, and there are links there. So make sure you check the description too. Let's see that. Thank you guys for watching. I hope you enjoyed the video. I hope this tutorial was useful for you. Have a nice day.